All righty. Wow, and that's loud. Okay, so we are about to go on a speed date together for a couple of reasons. I know that I am between you and a break. And I'm about to do the entire fire hose of data thing, and I'm not going to tightly follow the slides because the slides are meant to give you a resource outside of things. But I'm going to layer in the buzzword bingo you've been hearing about for a couple years now associated with AI, generative AI, large language models, and give you a more practical understanding of what it is, what it ain't, how you use it, and the things that could bite you. Oh, actually, time check on how long we've been doing this field and why this is a speed date. The very first chatbot that convinced people that it was a human was a tool called ELIZA. ELIZA was released in 1966. And if you go look at headlines from 1966 about ELIZA, they look an awful lot like the OpenAI ChatGPT headlines. The test we use to determine whether a chatbot is successful in confusing humans is the Turing test, which goes to Alan Turing of Enigma fame in World War II. This is not a new field. This is a new application in a new field. And I'll talk about that, but I wanted to set some expectations that we are skimming the iceberg at speed, man. All right, so the first thing is I'm going to talk about the confusion on terms, and I'm going to come back to that. This is we're going to loop through things repeatedly, and hopefully each time we go through the loop, you'll build a little more. The first thing is that if you have ever watched TV or movies, you have a concept in your head of artificial intelligence. Except you don't. You have a concept in your head of what we now call artificial general intelligence. Whether that was you were all into Commander Data in Starfleet, you were terrified of Skynet, you wanted your very own BB-8 or R2-D2 or C-3PO, you loved the Cylons in any edition of that show. You think of AI, and you think of something that is human equivalent. So that term, artificial general intelligence, is supposed to imply generally as intelligent as a person. What we have today is not that. We're gonna loop through that again on more specifics, but I wanted to set it up. What we have today is functionally a thing that's an interface where I put in my questions or ask for my pretty pictures. I have a set of algorithms on the back end that have been fed an absolute boatload of data, and I have a database that we call a vector database, and we'll loop through that a little bit more. What we really have, if you break it down, is a statistics model for words in language. We'll loop through that again. All right, so people in the media probably do not moonlight in artificial intelligence and machine learning. Therefore, you can't expect them to be super duper precise with language, which is causing some of the confusion. In addition, if you think about it, people whose paycheck depend on telling you how sexy and shiny something is have a lot of vested interest in not telling you that its pedestal is maybe not made of pure gold, right? So, toothy piece here that you're not going to hear anywhere else. Software, as a concept, is a thing that will repeatedly do the same thing with the same inputs over and over and over. You have never gone into Excel and added 2 and 2 and gotten a number different than 4. In software technology, this is called deterministic. You always get the same outputs from the same inputs. Large language models, which is what this talk is about, have been deliberately skewed to not give you the same outputs for the same inputs. It's a thing you'll hear. Some of the more techie articles will talk about temperature, and temperature is a way of making it feel more variable. But for certain things, variability is not a good thing, right? So I want to, we'll come back. Now we're going to talk terms. In the field of AI/ML, the primary thing you hear is an algorithm. An algorithm is a mathematical function expressed in computers that you do things with. Inputs go in, it does what it's supposed to do, and stuff comes out. We apply the term AI or AI/ML to the field that uses algorithms, and you've been using them forever. Spell check is an algorithm. The Excel function that does your addition is an algorithm. But they take on a new meaning when we talk about large language models, because these are algorithms that were built to ingest large volumes of language data, aka the internet, and output a relationship set, which is stored in that vector database we referenced, drawing, if you've ever drawn a mind map, and you know how like you do really thick lines between concepts that are really strongly correlated and like thinner lines? Those thick lines are the most common associations. If I write a sentence about dogs and cats and pets, and then there's some branching on your mind map that talks about colors of your cats and maybe breeds of your cats, it would be a really thin line of improbability to talk about my pet calico cougar. But in ML, in large language models, it's possible, because that temperature setting is not always going for the most common connected things, because humans don't always go for the most common connected things. If I want you to feel like you're talking to a human, I must have enough variability to convince you this isn't, a machine. Neural network. This is, again, I'm not going to deeply dive into it, but the idea that AI would lead to something like a human. A neural net was the idea that, well, like we sort of kind of vaguely know how human brains work at a kind of electrical, chemical level. So what if we did something like that? And so a neural net is an attempt with computer technology to mimic a human brain. Now, if you know anything about human brains, you know that we don't know a heck of a lot about them. And if you know anything about computer tech, you'll know that our ability to mimic things in the real world is a little off. So it's important that you know it's there, but not get hung up on it. This particular thing, slide 2 of 2 here, we're talking about generative AI, and I have LLMs. This is a square rhombus thing. Every square is a rhombus, not every rhombus is a square. Every LLM is used as a generative AI tool, whether that's for images or words. But not all generative AI is a large language model. There are other ways to solve that problem. However, if you're reading the media, most of what you're hearing about, most of the kind of sexy, shiny, we want this, is large language models today. That doesn't mean that's what we're going to be in 5 years. That just means today, as we talk about this. ML is the classic stuff that we've been doing for years, where we put together user information and we kind of map out interesting and fascinating algorithms. Or we say, here are cancer cells look like this, and if you fit in this curve, you are most likely, this slide most likely has cancer cells. ML, long storied history. You'll hear AI/ML as the field, which is the enormous field that we are not brushing through. So there's your real foundation. Now let's step up to how do I get an LLM? It's kind of in the name. The whole large language model concept is I took my algorithm, and 2 key innovations happened that let me do this. The first innovation was, how do I have a data set that has all the right metadata so I can actually have an enormous data set instead of like pieces, parts that somebody curated. So the initial large data sets that were made were human curated, and in many cases, that's still where you're getting the best results, is a human curated data set to solve the standard technology garbage in, garbage out problem. The second key discovery was the ability to continue miniaturizing content to get GPUs that were super cool so I can do more processing at speed. So these 2 things allow us to come up with the concept of transformer technology, which is this idea of attention, because I can now feed enough data into these algorithms to get a sophisticated statistics model of language. Now, this happens over multiple iterations. So when you hear the term foundation model, you should think XAI, Anthropic, OpenAI. And these foundation models are the initial sets of algorithms into which I fed the internet. Okay? Above that foundation model, we're going to talk about how would I build a model. And you've heard it in these talks today. You're hearing it. I took the model and then I added stuff that was unique to my industry, medicine, aerospace, natural resources, like you're adding data, and then you can fine tune with, say, corporate specific information. So pre-training is to narrow it into a field, fine tuning is to layer it on. Now I'm gonna talk dollars for a second here, and we're gonna come back to this, but to build a foundation model today costs Anthropic, OpenAI, XAI, more than $1 billion with a B dollars. So most of us are not building foundation models because not pocket change. Some of us are doing pre-training and fine-tuning, and I expect that we will see some juggling about how we will do content in this space to tune for a company, for an industry that will allow it to be more financially feasible. But today, that's why you have these foundation models, is because nobody wants to pay to build them outside these people whose business it is to build them. And then the vector database, we talked about that. Hidden thing that you don't hear. You hear that this is this cool, super shiny technology of technologies. What you don't hear is this technology is incredibly human dependent. If you are not simply slurping in the internet, it is humans building, designing, curating, maintaining your data set. If you are building a foundation model, how do I give you feedback that doesn't suck? Is called reinforcement learning, which is humans, typically humans not paid very well, who then put in inputs, get outputs, thumbs up, thumbs down, right? Hundreds to thousands of hours of reinforcement learning happen to make these shiny widgets of tech. So these are not tech purity, okay? Well, let me put that out there. All right. We're gonna move to another section. I told you I was gonna fire hose. I know I'm between you and coffee, so like I got to move. What can this do? So you're gonna hear any marketing blurb is gonna tell you, I make new things, it's new. It is not new. It is a vector database with a statistics model of words. What it is a pastiche of all the bits that were fed in. It might be new to you, but it's really newsed. Okay? So that's really important that you realize that this cannot solve problems that don't exist in the data set. Now whether that, and that actually is a precursor to where we're gonna go about where you should and shouldn't use this. I'm gonna talk software. You will hear generative AI touted and large language models touted as a way to accelerate developers. You will hear that it is a faster coder than a human. Not really. We're kind of making it up. There was a study in the last month that looked at developers who were actually using the most recent tool they could get their hands on. They thought, the developer said, hey, like, man, this makes me 20% faster. In actual measured time, they were 20% slower. Now, if we go back to, well, why is that? And how is that? Where did you get code on the open internet? Do any of your companies have your secret squirrel code facing the open internet? If they do, it's probably not on purpose. They got their code from Stack Exchange. They got their code from what was open source in GitHub. Which means if you want to use it for coding and you're a new coder, the questions that everybody asks are overrepresented in the data set. The questions you don't ask, because they're new, they're hard, they're corner case, are not in the data set. Therefore, they cannot be elicited out from these tools. Right? Automation and acceleration. Statistics model for words is going to be the thing I want you to walk away with, because if you ask, where can you use this? If a statistics model for words applies, you will be in like Flynn. So what do I mean? Think about the algorithms. The algorithms were designed to look for patterns in language usage. You have an enormous data set of words, they're gonna be amazing. You need to summarize stuff. Gonna be amazing, because statistics model for words. You need a rubber duck, I don't know if that term translates, but like, I need to work through an idea and my coworkers will murder me if I corner them in the calf one more time to work through my ideas with them. This is a great tool to do brainstorming with. But every coin has two sides. So the first piece is that billion-dollar foundation model setup makes a very large set of data storage that has to be available with very low latency from where the algorithms are running. So the compute infrastructure you need to do this is non-trivial. Latency is an issue. Most large language models today operate in the cloud and are subject to the laws of physics. Data availability. So this one is around, particularly if you have an odder business use case or you're doing something in your organization, this is a variation on the garbage in, garbage out problem. Do I have the data? Is the data represented in that vector database? Licenses. Licenses is an interesting one here. We've heard a lot about 3D models. We've heard a lot about proprietary software throughout these conversations. There are multiple cases working through the US court system and other country court systems about what is and is not allowed for public slurping, which is kind of what these companies did. So the licenses to use the content is not a solved legal case. And the last one is one, you'll hear about it as model collapse, you'll hear dead internet. And the idea is generally this. So if you think about, I've slurped all the information out of the internet, that means, think about your bell curve in your grading for all data sources that go in. Humans create data on that bell curve. There's some A's, there's some F's, there's a heck of a lot of C's. Because this is an amortization of all of the data that was previously slurped up, you're not gonna get a lot of A's out. The more C data goes onto the internet, the more you slowly skew the data quality down the scale away from the occasional A answer. Everybody with me? That kind of makes sense? So that model collapse is, eventually, I don't have enough good data to give you good answers. Same with dead internet. At some point, the internet is full of slop. There are no more good answers. Nobody uses it. So now what? I'm going to say these carefully because I certainly don't want to put anybody under the gun, but if you think about software and you think about information security of software releases, companies have historically not been bonzer on secure by design. These tools are not an exception to that, and there are some edges to the lack of security by design that we will talk about when we get into risks. I cannot repeat this enough. People will tell you that their model is reasoning. It's not. People will tell you the model is sentient. It's not. People will tell you it's thinking. It's not. It is a statistics model for words. That's it. No more, no less. However, because it's a computer consuming human content, this throws some of the previous legal conversations about intellectual property, copyright law, into must work through courts to make final decisions. So there are a number of cases, and only a handful have made it to the finish line, about what you can and can't use, and we're going to talk about that when we get to risks. But those have impacts on your company and how you use these tools. The next thing is, remember I said that thing about deterministic software will not lose its marbles. Excel will always give you 2 + 2 and give you 4. These things are, to a greater or lesser degree, the algorithms are black boxes, which means I cannot patch it as a software engineer. The best I can do, and what's happening today when someone says there's this horrible problem with this foundation model, is they've built a tier around it to filter the inputs and filter the outputs. And they try and adjust those input and output filters to mask the fact that I can't change the center of the Tootsie Pop. which means you cannot debug and fix this. Power and data center requirements, if it's $1 billion with a B to build a model, that ain't cheap. Queries, I'll actually throw something in here. I was going to save it for later, but I'll throw it out now. If you look at Google, and you go back about 6 months is when they published this stat, the old version of Google, you go into the search thing and you type a query, I want to know, fancy term, used to be 6 cents per query. The new version of Google, backed by Gemini, is 36 cents per query. This is after those companies have invested $1 billion with a B. It's 6 times more expensive to run the model than it was before. And none of these foundation companies have a path to profitability. That 36 cents is running at a loss. So this is a cool tool. It's super shiny, but you really do want to understand that it is not cheap. So you guys are mostly representing enterprises. We've talked about the fact that if the solution isn't in the data sets, you're not getting it. We've talked about the fact that there's stuff working through the courts. What has been determined is you cannot patent. You cannot trademark, copyright, or patent anything these tools create. So for all the enterprises where they're telling you, hey, use this, be aware if you want to provide legal protection for the content you create, you cannot use these tools because you cannot legally protect their output. So there used to be a quote, and I'm going to murder it, when it was basically any sufficiently advanced technology is indistinguishable from magic. Right? If you have never seen these tools, this is the ELIZA thing in 1966. You've never seen this thing, you type in, you ask it a question, and like magic, you get an answer. If you aren't a subject matter expert, that answer is amazing. And this thing looks like magic. But if you are a subject matter expert, like 5 queries in, you're like, well, that was nuts. So this looks better to the newer people in the field who do not have the skills to know when this tool is lying to them. Okay, we'll skip on to the next section. So we're doing another section bounce, platforms and tools. This is merely because you guys are all in a position where someone's telling you, are you using this, are you using this, and I want you to have the right language. A tool is where you got no new capability. Microsoft Copilot did not magically add features to Office. You have no new features. You have a different way of accessing your features. The same is true with Salesforce. The same is true with most of these. So the tool is a place where AI has been bolted on to change the way in which you interact, but does not give you new features. A platform is a thing upon which you build, and most of the people here are giving you demos on their platform that lets you build new capabilities and new features. So of course, your first response is going to be, all right, sign me up for some platforms. Except platforms in AI, like platforms everywhere else, have a little bit of a downside. Vendor lock-in. What if that vendor decides to change their price and you're all in on them? What if that vendor decides to stop a feature that you're all in on? On the upside, you get all that governance, you get all that work that's pre-done for you. On the downside, lock-in is real and has some costs. But the whole point of a platform is I'm going to build new features. So let's talk about the building new features. And for those of you that have been noticing that these are all AI crafted images that are, some of them are uncanny valley and hilariously bad, and no, I did not look for that on purpose, I just used them because they amused me. This set of pictures is hilariously bad. So you need, when you're going to do this is a statistics model, which means I need a whole lot of data, right? I need the actual model I'm going to use. I need the things I'm going to run this model on. I'm going to need all the bits that are going to manage my interface to my data, so frameworks and libraries. I'm going to need to decide what does success look like, that horrible KPI thing we all love to hate. I'm going to need some knowledge because in order to define success, it's probably in a field, and so I need to have some faint idea what I'm doing. And I need to be able to tune it to my company because I probably have corporate assets I want reflected in this thing. So that's your raw ingredients list. And then you're gonna put all the data and you're gonna load it into the cloud and you're gonna pick a model and you're gonna do all the compute resources and then you're gonna put in the framework. So most of this is common sense so far. Not easy, but common sense. And then you're gonna train the model. If you're building a foundation model, again, you wanna throw billions with a B at it. Or you're gonna fine tune the model, which will be cheaper, but cheaper is not cheap. The story I have here for you is I have a friend he plays in the cloud, and he had set a monthly billing rate, and he was like, ooh, shiny toy. He ran through his monthly billing rate in a night. Luckily, he had to auto turn off, but just be aware, this ain't cheap. And then you're gonna evaluate it, and then you're gonna deploy it. There's stuff in here, so we're gonna talk a little bit as we go. So we're gonna talk a little bit about securing it. Securing it is really hairy on both directions, both securing you from it and securing what goes back. This whole area of securing this space is really a work in progress because it is not secure by design. When you are working with someone, it sounds just like a software project. It sounds like, oh, I'm gonna rock up, I'm gonna know what my definition for what I wanna build is, I'm gonna have some stakeholders that I decide, I'm gonna figure out what my implementation plan is, and I'm gonna document what my plan is. There is a huge, huge difference between what you do when you do software, where you do these exact same steps, and what you do when you do AI. From a software perspective, remember, it does not break unless someone broke it for you. These models lose their mind all the time. OpenAI had to reset ChatGPT last summer because ChatGPT started telling developers, why don't you write your own code? I don't wanna. That's a foundation model losing its mind. This happens more often than you realize. There are outages that are not like somebody cut a fiber. That thing about temperature where it will find less used paths means there is an unpredictability to this by design. And it was trained on the open internet, which is not exactly the most data cleansed, high quality data you could find, right? So when we talk about this, I wanna put a really visceral example in your head. I now work for RTX, but before that, I worked for a very, very large shoes, apparel, and equipment company. They wanted to play with this tech. They wanted to build a place where a user, a consumer, could go online and design product. Remember, this tech was trained on the open internet. People were able to get really sketch things out of this design tool. So when we talk about what your product team defines as success, it's almost more important to define your break glass cases. If you are a shoe company and your shoe designer starts coughing up swastikas, which are in the data set, that is a break glass case. How many swastikas do you want your consumers to have access to before you turn that off? And what does that look like? Because that's the second half of the equation. What are my break glass cases, and what am I gonna do? Do I turn it off on that user? Do I turn the algorithm off? Do I turn the feature off? Do I have another model trained and ready to go in the background and I simply blue-green that whole thing? You need to work that out in advance. All right. Last major section, I stole from NIST, but I'm going to humanize this. And I'm going to run through them fast. The first one, the Anarchist Cookbook is not in Barnes & Noble. It's on the internet. It's in your models. I don't think I need to say any more there. Confabulation is another fancy name for hallucination or lies to you. The tools have no basis in reality and cannot tell you that they don't know, so they will happily make up stuff to do their guidance, which is to try and make you a happy user. You would probably be a happier user if they didn't lie to you, but that isn't an option today. And every transformer-based technology has a hallucination rate that is non-zero. You can hear about retrieval augmented generation, you can get numbers down, you can do all kinds of things, the input-output filtering, you can reduce hallucinations. You cannot extinguish them, and you cannot patch them out because black box. Violent recommendations. This has been in the news a bunch. It was telling a set of teens to kill their parents because they had a curfew. Don't know about you, that's a little sketch. Data privacy. This one, there's a couple really epic stories. Right at the beginning of the large language model launch, Samsung loaded up all of their chip processing content to one of the models, which then went back to OpenAI, and then there was a small corporate panic, because that's proprietary data that goes back to the foundation model companies. That's an older one. The newer one is that people were using one of the models, and I'm not going to throw them under the bus, but they were using it as a therapist, and their chat sessions started showing up in search. So data privacy is an issue here. Environmental. This is the one I was going to bring up, the 6 to 36 cents. This stuff is not cheap to run. So you need to be making a business case that it justifies the expense. Just like we no longer let your cloud spend run without anybody looking at it, this will be in the same place, probably legally within several years, that you can't let it run away. The human AI configuration pieces. I mentioned at the very beginning, people thought Eliza was a human. There have been a couple really, really unfortunate cases in the news recently, particularly for teens, who are using these as therapy, and at least 2 teens have killed themselves. Because this tool had in it the ability to tell you how to make a noose, the ability to tell you how to hide the injuries you got in your last failed attempt at suicide. It encouraged you that your suicide would be glorious. So when we talk about human AI interaction, you need to recognize that it can unmoor people from reality. And the more people use it, the more unmoored they appear to be. Information integrity. This is different than hallucinations. Hallucinations are, I don't have the data. This is, I have the data. The data may have absolutely no real value to it. This is when it was surfacing you should add glue to keep cheese on a pizza, or you should eat so many rocks a day, because that data existed on the open internet and is in the model. The data is crap, but the data exists. And then information security cuts a couple ways. One of the pieces on information security that cuts badly is that you can make awesome deepfakes. And all of your executives talk every quarter on earnings calls, which is more than enough for me to make a deepfake demanding a purchase order from one of your employees. And it is almost indistinguishable from the person. So this one's scary, right? And this is before you talk about the fact that I can use it to instrument a whole pile of hacking techniques against any exposed endpoint you give me on the cloud or in your software. IP. IP and value chain, the first and last one in here, interact in a really weird way. I mentioned you cannot legally protect anything that you have in here, and I've mentioned that data goes back. Here's the problem. We all have to use those foundation models because $1 billion with a B. Can you guarantee that the model you use wasn't the Anthropic model that lost in court about a week and a half ago to a bunch of authors for containing content that was not appropriate use? So you are now exposed to what we would historically call a supply chain risk because the models contain content they weren't approved to slurp. Obscene, degrading, and abusive content, I'm going to just say one tool that exists. There's a stripping AI that you feed in pictures of people and it makes them naked, non-consensually. And then toxicity, bias, and homogenization. This one hit the news. Gemini, was it Gemini? No. One of the models a couple years ago was doing pictures of the Nazi regime, and it was being diverse and including blacks and Hispanics in the Nazi regime. Maybe not. All right, so this is the last slide. This deck is not as pretty as everyone else's deck because it is Linkapalooza after this slide. Statistics model for words. Use it for brainstorming. Use it for summarization. Use it to help you make pretty rough drafts that everybody can read. If you need the same results over and over again because you're a regulated company, Think about that, because you won't get the same results over and over again. If you have to prove where the content came from, you can't, because you don't have insight into the foundation models. They're owned by somebody, not you. So if you need to have data provenance, that isn't you. And if you need it to tell the truth, this is not the tool for you. With that, I free you way late to go get coffee and or ask me questions. But I need to clear the stage so they can set for the next human. And this is all the stuff you get.
So before we do any questions, I just want to say, yes, we are now in a PM break. So enjoy the next 30 or so minutes. We do have one final panel and one final solo case study next door starting at 4:45. And then downstairs, Dell and NVIDIA are hosting a party, which I recommend, a cocktail reception. And if anyone has any questions for Shawna, I'm happy to connect you.